plus 4x cubed
Mm-hmm.
plus 4x 5x power 4.
Okay, right. And this is the derivative when you use infinite polynomial. If I want to change it into series, then you can say that when you differentiate, as I said, whenever the power is just n, okay, integer n, the starting point is always increased by 1. Why? Because every time you differentiate integer n, okay, the first term is always 0. That's why you start with 1. And then remember when we use Taylor series, the same technique applies when you use polynomial. Bring the n to the front. So I have n minus 1 to power n and x, and what happened to the power of x?
N minus 1.
Yes, very good. Betul ke ni? So kita check balik. Saya ambil pen mana lain. Okay. Bila kita masuk, the starting is 1. So when you put 1 minus 1 to power 1, x to power of 0. So jawapannya apa? Minus 1 betul tak? X power 0 is 1. Minus 1 to power of 1 is minus 1. Darab 1, still minus 1. Okay? And then when you, term kedua 2. 2 minus 1 to power of 2, x to power 2 minus 1. Dia dapat apa? 2 kali 1 sebab power 2. X 2 tolak 1 adalah x kuasa 1. Nampak tak? Sama tak dia dengan yang atas ni tadi? Okay, tolak when n equals to 3. 3, negatif 1 kuasa 3 dia jadi negatif ya sebab dia odd. Right? X kuasa 3 tolak 1 jadi 2. Sama ke tak? Masuk pula n equals to 4. Okay. 4, negatif 1 kuasa 4 genap jadi 1. X 4 tolak 1 jadi 3. That's why ikan dapat 4 kuasa 3 dan seterusnya sama sebiji. And then sebenarnya ini juga boleh kita buat dalam, kita tahu kan how do you differentiate inverse polynomial. Macam mana nak inverse polynomial, how do you differentiate? Bring the negatif 1 ke depan, betul tak? Negatif 1 tambah x kuasa berapa? Tak ingat dah.
Negatif 2.
Negatif 2 darabkan dengan perkali of x kan? Fungsi tersirat implicit differentiation ni adalah 1. So jawapannya adalah negatif 1 per 1 tambah x kuasa 2. Ini secara inverse polynomial. Yang ini adalah secara power series. Dan ini adalah secara infinite polynomial. So ada 3 bentuk yang kita belajar. For today, in our syllabus, kita nak belajar yang ni. Saya tukar colour lah, hijau lah. Okay, yang ini yang saya nak. Dalam our problem later on, we are dealing with series. Are you okay, Liana? So yang ini yang saya perlu buat tulis. Fx tu apa? Series tu apa? No need to expand it. Tapi kalau nak expand supaya nak lebih faham, yes. So jadi tak perlu buat yang ni sebenarnya. Mana pen saya tadi? Yang ni tak perlu buat sebenarnya. Memadai dengan macam ni je jawapannya. Okay, memadai dengan menulis this is the function in inverse polynomial. This will be the series. When I expand it, I dapat infinite polynomial. When I differentiate infinite polynomial dapat macam ni, but my series after derivative is this one. So ini cara penyelesaian. Kalau nak, tapi when we did later on how to differentiate, kita tak perlu guna expansion of infinite polynomial lagi. Are you okay, Liana, and the rest of you? Are you okay? And then you can do a problem 18, 19, and 20. But expand in infinite polynomial and then find the derivative using power series. Ingat dia punya formula is just the same when you differentiate polynomial. Bring the power to the front and then the power minus 1. Remember, whenever it's a positive integer, the starting point of the derivative should always increase by 1. Kecuali whenever you have the power is n plus some positive number or negative number of real numbers. Boleh? Saya dah ajar kat step 2 hari tu. Ni. Mana dia? Differentiation of opposite. Ada apa-apa persoalan? Atau balik mana muka awak? Saya tak nampak. Ada apa-apa persoalan? Sekarang ada baru 47 orang. Kita ada 53 dalam kelas ni, bermaksud 6 orang lagi masih lagi tidur. Okay, any other question? Tak ada ya? Exercise 1? No. Now we continue with the, baliklah ya. We've done differentiation, we've done with shifting, okay. And today we continue how to do it, and done, how to do Taylor series. Okay. So before we continue using a Taylor series, right, we have to know why and when to use Taylor series. Taylor series is just a tool or method to convert any any panjang warna pula yang dia ya. Any non-polynomial function to series. Are you okay? Bermaksud mana-mana non-polynomial function to series, mana-mana non-polynomial function we want to convert to series, this is the method to use. This is the tool to use. Contoh yang saya bagi, kita nak selesaikan ODE. Okay, our ODE is y double prime, mana pergilah prime sebelah ni, plus 2x y prime plus cosine of x darab y equals to 0. Buku betul tulisan orang tua ni. Okay, I put in a bracket. So whenever we have a polynomial with derivative, it will be much easier to solve, right? But with non-polynomial will be impossible. Contoh ya, katalah y prime tu saya tukar je lah ya. Ini contoh n equal to 0, 3 x to power of n. Okay. Kalau saya simplify this, can I multiply this inside? Yes or no?
Yes.
Yes. Because 2x, because this one is just series. Sama dengan 3 tambah 3x tambah 3x kuasa 2 dan dot. Betul tak? Ni series ni kan? Ni sama. So maksudnya 2x ni boleh je darab ke dalam, betul tak? So series pun begitu. Because this what we have series is just infinite polynomial. Boleh darab dengan mana-mana polynomial. Apa jawapan dia? 2 darab 3, 2 darab semua 3 ni dia jadi 6. X darab X kuasa N dapat apa? Bila X didarabkan dengan X kuasa N, jawapannya apa? Remember index? A, M darab A, N sama dengan A?
M plus N.
Very good. The same concept applies here. So X darab X power N, jawapannya apa?
N plus 1.
Yes, very good. Very good. Is it Raymond? Who talked just now? Is it you, Raymond?
Saya doktor.
Who are you?
Arman.
Arman. Lebih kurang Arman Raymond tak apalah. Arman So here the value will be N plus 1. Barulah kita boleh selesaikan. Because our problem is all in terms of series, right? But I have cosine of X. Kalau cosine of X didarabkan dengan, ni kan kita punya ni adalah X power N. Apa jawapan? Maksudnya cosine kita didarabkan dengan 1, X kuasa 1, X kuasa 2, X kuasa 3 dan seterusnya. Betul tak yang ini? Series. Boleh tak cosine darab ni semua? Bermaksud dalam ni semua ada cosine, tak berubah, betul tak? Dan kita tak akan dapat selesaikan bila ada cosine of X. Because cosine of X bukan keluarga trigo sebab bila masuk ni, nampak macam boleh but when we convert to series, kita masih ada lagi dalam sebutan trigo. Series kita ada trigo, bukan infinite polynomial lagi. Kau faham tak ni? So that's why kita tukarkan cosine of X ini kepada polynomial, because polynomial darab polynomial kita boleh merge. Macam ni nampak dia boleh merge. But cosine of X dia tak boleh merge. Okay, so that's why we use Taylor series. When to use? Inilah whenever we have non-polynomial function, so we need to use Taylor series. Are you okay so far? Right. So this will be the formula. Fx equal to series, the nth derivative of x naught, x minus x naught to the power of n divided by n factorial. Remember, x naught is just the center of the series, n is the power, n factorial. What is n factorial, by the way? When I have 5 factorial, what does it mean, 5 factorial? What does it mean by 4 factorial? This is equal to what, 4 factorial? Anyone? None of you are talking. Do you remember?
4 darab 3 darab 2 darab 1.
Betul. 4 darab 3 darab 2 darab 1. Kalau ada 100 darab 100 factorial maksudnya 100 darab 99, darab 98, darab 97, darab 90 sampailah yang terakhir sekali mesti 1. Alright. So this is it. And then looking at the notation. Nampak tak ni? I'm looking is nth derivative And please take note the nth derivative yang ini tak sama dengan f power of n. Apa bezanya nth derivative dengan power n? Okay, saya tunjuk kat sini. Sini aje lah Padam yang ni. Sepatutnya saya bagi a new, what do you call it, a blank piece of paper, right? Senang nak ni, tak payah nak padam-padam. Okay. What's the difference between nth derivative and n? Let's say my function of x is 2 squared, 2x squared, 2x. What if the power of 2 for your function? What will be the answer? It means my F is time another F, right? So the answer will be
0.
0.
4x square.
4x squared. Kalau saya ada the second derivative, jawapannya apa? First derivative jawapannya 2. Second derivative jawapannya, barulah nampak kosong. Siapa sebut kosong tadi? Derivative, nampak tak yang ni? Berbeza. Yang ini adalah sama dengan 2. Nampak tak tata tanda notasi yang saya guna? With and without bracket means differently. 2 means power. In bracket means derivative. Oh, baik. Jangan buruk tu. Derivative. Please take note of that. Alright. Someone wants to join. Allah Akbar. Patah balik kat sini. Someone to join. Dah. Masuk. Mana tadi? Video on pause. Okay. Nampak Kenapa berbeza? Alright. Kenapa ada prime, second prime ni sama dengan what do you call it? 2 dalam bracket. Okay. If we want power, kita selalu gunakan Greek notation atau ini Greek numbers. This is what we call Greek numbers ataupun English numbers 1, 2, 3, 4, 5 yang kita biasa guna hari-hari. Kita gunakan dalam maknanya adalah power, tapi bila kita guna derivative, kita guna tanda prime, betul tak? 1 prime, 2 prime, 3 prime, 4 je na? Anyone?
4 titik.
Macam dia? Macam ni
4 titik.
4? Arman,
Titik.
is it Arman? Did you say 4 apa? Betul ya saya buat ni Arman?
Boleh, betul-betul.
Betul. Okay. Remember, sesiapa ada jam Roman numbers? Ni pukul 1. Lepas tu pukul 2. Lepas tu pukul 3. Lepas 3 pukul 4 je mana rupa Roman numbers? Saya tak ingat sebab saya tahu 1, 2, 3 je. Roman numbers yang keempat macam mana?
IV.
1, 2, 2 pula V. Yang kelima V.
VI.
Yang keenam untuk derivatif sebenarnya kita menggunakan Roman number tapi italic Roman number. That's why kita dapat macam ni. So yang keempat derivatif macam mana sebenarnya? Empat derivatif macam mana sebenarnya? Oh, faham tak siapa saya cakap?
IV tapi
IV.
Betul. Italic IV, italic V and italic V1. Bukan ini ya. Kena faham. Jangan buat. Kalau nak 10 je no pula. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Macam tu ke you buat? No. Tak ada such thing. Robinson Crusoe yang terduduk ke island tu. Pernah dengar tak cerita, pernah baca ke Robinson Crusoe? Stranded in an island. Dia buat ni betul. Nak kira hari. Tapi dia pun tak buat macam tu. Dia 1, 2, 3, 4. 1, 2, 3, 4. Dah ratus hari dia duduk kat island tu. Tahu tak? This is, we call it frequency yang kita belajar dalam statistik. But we never do this. Kena ingat, derivative adalah Roman number. I don't know you all, mungkin you all terror lah 1 sampai 12. But I don't remember. What I know is Greek numbers, English number ni 1, 2, 3, 4 no problem. Saya nak 1000 pun saya boleh tulis 1000 gitu. 999 no problem. But 999 in Roman number saya tak tahu. So that's why mathematician and engineer sepakat kata, right, kalau tak ingat tulislah dalam bentuk bracket macam ni. Nampak? Whenever you bracket the English number, the Greek number, it means derivative. Boleh ya? Faham tak ni? So saya tak nak ada lagi berlaku kesilapan yang ni. Ni. Okay. So tengok apa yang saya buat. Okay. First derivative, second derivative, third derivative. Bila 4 saya dah tak ingat, dah saya tulis nombor 4, put in a bracket. Are you okay? Ya, macam aku lah ni senyap je. Kalau ada 100 orang semua.
Okay, madam.
Alhamdulillah. Right, so for the example here, again, I'm looking at cosine because this is non-polynomial. I would like to ask you, do you know what is non-polynomial? Kita nak cari. I need blank papers. Paper. Sekejap Okay, my notes. Kita ambil tutorial 3 mana? Susah tak ada blank paper ni. What do you know about non-polynomial and polynomial functions? You have learned this, right? Dari darjah 1 lagi dah belajar. Darjah 1 tak lah ya, darjah 6. Sorry. Ni kan ada blank paper. Right. So what I want to know whether you understand the distinguish between polynomial function versus non-polynomial function. Okay, give me an example of polynomial function. Abang sulung dia apa? Polynomial function.
X square.
Itu yang Kak Lang nombor 3 X squared. Yang pertama, yang sulung. Yang pertama adalah constant polynomial. Yang kedua, abangah dia siapa? Dia balong. Abangah dia siapa? You sebut tadi X squared dah. AX. Tadi permada. Yang sebut A plus BX plus CX kuasa 2. Ini adalah yang nombor 3 ya. Kak Lang dia kuadratik. Macam mana jalan? Kuadratik polinomial. Abangah dia siapa?
Mac.
Apa dia?
X, madam.
Yang nombor 2 dia abangah dia siapa? Dia dah sebut tadi, tak apa nak dengar. Apa dia? Nama dia siapa?
AX squared.
AX.
Nama.
Nama dia siapa? A plus BX, right?
Mac. Daryl.
Maksud saya. Okay, Daryl. Lydia. Betul. Thank you, Daryl. Lydia. Yang keempat. Adik dia lagi yang keempat ni.
Cubic.
Yes. Yang keempat namanya cubic.
X kuasa 3.
Betul. Tambah CX kuasa 2 tambah DX kuasa 3. Kemudian dan seterusnya, am I right? Saya nama keluarga polinomial banyak sangat. Saya sampai 4 beradik yang atas ni saya ingat. Bawah-bawah tu saya tak ingat dah. Sama lah juga macam manusia kan. Anak yang mula-mula tu dia ingat lah. Yang last anak nombor 10 tak tahu dah nama siapa. Faham tak ni? Banyak sangat. Because polynomial function ada banyak. always remember the abang long is constant, abang is linear, Kak Lang di quadratic, and then yang keempat adalah cubic polynomial. Dan after tu should be apa? Quadruple is it? Yang kedua empat, tak ingatlah namanya. Okay, now we are looking at non-poly, keluarga non-polynomial function. What are they? Bukan poly, tak nak yang ni. Yang bukan keluarga polinomial. Ada banyak keluarga yang non-polynomial function. Contoh, keluarga pertama. Jiran depan rumah. Jiran depan rumah polinomial ni, siapa? Yang sebut kita tadi kan? Cosine of X, sin of X, tangent of X, lagi apa? Secant of theta, cosecant of 3M. Ini adalah keluarga apa?
Trigo.
This is keluarga trigonometric function. Okay, different from polynomial. These are non-polynomial. Lain, jiran belakang rumah siapa?
ln X.
Pardon? Oh yes, natural log X, logaritma asas 10, M, logaritma asas 2, D, natural law of 3 theta. Ini adalah keluarga apa? Yang lady. Nama dia tak ada.
Logarithmic.
Logarithmic. Sekejap anda tahu sana. Logarithmic function. Okay, next. Keluarga apa lagi ada? Yang jiran sebelah kanan pula.
X negative 2.
X negative 2. Are you talking about this one?
Power negative 2.
Power negative 2, X power negative 2. Sekejap silap. X, mana? X power negative 2. This is equals to 1 over X squared. Well, yeah, correct. So what do we call this?
Inverse function.
Yes, inverse function. You may have not just the inverse function, you may have, because this one is abang long, divided by quadratic, betul? Okay, let's say I have a linear divided by cubic, X kuasa 3 tambah 4X tambah 3. Right? This is another function dalam kategori ni juga. Kita panggil apa ni? Dekat sini, ini even though this is linear bahagi dengan cubic, walaupun function asasnya adalah polynomial, but whenever you put in a form of fraction kan ya? Is it Arman? Dara yang sebut tadi, sorry lah. Tak berapa nak dengar suara. Saya masih lagi tak cam suara awak. Right? Whenever you have polynomial in a form of fraction, it will be no longer polynomial. Sebab dia dah kahwin dengan, Abang Long dah kahwin dengan Kak Lang. So that will be a different family. Kita panggil family apa ni? Rational function. This is no longer a family. Sama lah macam kita, whenever you have a son, marry another one, they will form another family. Bukanlah kita masuk dalam family kita, betul tak? Sama juga dengan ni, polynomial. Whenever you have a son, constant poly, tiba-tiba kahwin pula dengan another girl, cubic poly, they will form another family which is rational function. Nampak tak ni? Lagi? Banyak sebenarnya. Lagi? Ni keluarga apa ni?
Exponential.
Ni keluarga exponential. Exponential function. Lagi? Inverse function, hyperbolic, trigonometric function, dan it goes on. Ada banyak list ya. Saya tak nak sebutlah, nanti Irfan carilah. Sebenarnya tekan je dalam calculator. Saya pun heran kenapa tak. You can always Google non-polynomial function dan boleh terus jawab dengan saya kan. Tapi none of you duduk senyap je kan. It's always there in your fingertips. Saya sebenarnya nak juga tanya you all sambil kita bincang ni, look into this, right? You can always browse through, tapi tak ada, none of you are doing that. Okay? Anyway, so done with that. Patah balik ke power series. Okay, so the example here we are looking at trigonometric function, which is non-polynomial function, and we want to solve at x naught equals to pi. Right, so the center of the series, the center of the problem that you want to solve is at pi. Okay, contoh sebab saya letak pi because Rego kalau pi ni senang nak calculate kan. So using Taylor series, so this is the first thing that you need to mention. Method. Nombor satu is always method. So this method converting non-polynomial to poly is always Taylor series. So that is the first thing that you need to do. As an engineer, you must be very, very careful with your instruction. Always start with a clear instruction. Barulah your contractor knows what to do in executing your blueprint. Betul tak? Batuk. Is it okay? Can you all hear me? And the second one is always the formula. This is the formula of Taylor series. And then once you get the formula, always expand it. Why? Because not everyone knows directly using the series. But if using infinite, senang. Tak ada masalah. Kita familiar with the infinite polynomial. So that's why we always expand. Once you're done with the expansion, method dah tahu, formula dah ada, right? So tengok, oh, we need to convert the cosine. So we have the function. We need to find the first derivative, second derivative, third derivative, fourth derivative, and goes on. At a point of x naught, and x naught is pi. So we need to find all this information in order to find the answers. So this is what you do. 3 is the working for the information that we need. Function is cosine of x. We want to find first derivative, second derivative, third derivative, and fourth derivative. Dan carilah derivative cosine dapat negative sign, differentiate sine dapat negative cosine, differentiate cosine dapat negative sign, and it goes on. Again, not just the derivative, but at the point of x naught. Apa x naught kita? Pi. So gantilah fx pi, f pi adalah cosine pi, negative 1. F prime of pi is negative sine pi, 0, and it goes on. Dapatlah 0, 1. And then, ni sama 3 dan 4. Third, this is still working the working for finding the derivative. 4 is the working finding the what do you call it, the value, right? Kenapa pula sekecil kan ni? Oh, okay. And the fifth one is when you substitute, this still working this is still working. You substitute all the information that you get in 3 and 4, masuklah dalam ni. The expansion of the formula, the infinite, masuk semua sebiji, kan? Okay, and that you simplify. Okay, ada kosong, letaklah kosong The second term is 0, so you put 0. The third term is 1, darab x minus 5, power 2, don't forget the factorial and it goes on. When you simplify, you dapat negatif 1 dengan 1, kosong buang je lah terus. Kan? X minus 5 over 2 dapat ini dan power 4. Remember 4 factorial is 24. So it's 1 over 24 plus dot dot dot. And this is number 6 is your answer, right? And then this will be the also conclusion saying that therefore, saya letak therefore, cosine of x is just infinite polynomial minus 1 plus a half x minus 5 squared minus 1 over 24 x minus 5 to the power 4 plus dot 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 at x not equals to 5. That will be your problem. This is how you do Taylor series. Are you okay so far? So in exercise 1, I have a lot of this, not a lot, but 2, 4, 6 questions that you may need to practice. This one kita dah buat dah tadi. So this is the inverse function yang your friend said just now. Simple one. This is the rational function. This is the logarithmic function. This is actually tak perlu but you may use cubic polynomial to convert, tapi sebenarnya tak perlu, right? And this one, ni keluarga apa dah? Ni keluarga apa ni? Yang ada square root function, alright? So itu sahaja. Ada apa-apa soalan? That is point number 5. Now we continue dalam sini okay. Again, I'm looking at exponent ada, trigo ada, natural log ada, it goes on, right? Kita di sini, right, we always use Taylor because our A can be any numbers. But whenever A is 0, is actually Maclaurin series. Sebenarnya sama lah dengan Taylor. Kalau masukkan A to 0, kita akan dapat lah Maclaurin. Maclaurin nak juga nama dia letak. Padahal sama je dengan Taylor series. So, for our syllabus, it is memadai. Cukup dengan hanya hafal this one. It is not given in the final exam. It's not given in the appendix. So, you need to memorize. So, it is enough to memorize Taylor series. Why? Because whenever you put 0, you're confirm akan dapat Maclaurin series. Right, so these are some of the jawapan yang tak ada. Ni, this is hyperbolic trigonometric function. Alright, this is the inverse trigonometric function. So banyak nak polynomial. This is trigo. This is exponential. This is the natural, the logarithmic function. This is the rational function. Right? Rational function. So ada banyak dah in the form of infinite polynomial and also the power series. Not all infinite polynomial can convert to series. It's not easy. But this one is done for you, so you make use of this as a guideline to do your what do you call it, Taylor series. Okay, so you can always read. This one is in from Zill's book. Banyak lagi buku. This one is from Zill. Right, so you can look into Zill's book. Ada banyak lagi, right? So yang ini adalah beberapa, ada banyak sebenarnya, right? Lagi beberapa soalan yang melibatkan this one Taylor series. Yang ini adalah radius of convergence ni in 455 So question number 1 until 8 ni tak perlu no need, because you are not responsible for 455 anymore in this class. Tak perlu pun tak apa, right? But you know how to do this, right? So tak perlulah I'm not going to question you on this, right? So these are again another problem regarding Taylor series that you may do. Kat sini ada banyak kan? 2, 4, 8. There's another 8 of this, ada 8 questions, right? And then we have another 6 dalam exercise 1. So kita ada 14 soalan, right? And then this one continue with derivative. 17 and 18 is how to differentiate. Yang ini is shifting, right? And the one is also shifting, right? Okay. Ada apa-apa soalan sebelum kita masuk point yang terakhir? Principle of superposition. Anyone? Saya tak nampak muka, tak tahu. Do you have anything that you want to ask? Okay, the last. You want to take a break? Ya, dia, Noreen?
Tak ada madam.
Tak ada. Do you want to take a break before we continue, or we just continue sampai habis?
Take a break.
Take a break. Okay, now it's 8:50. So we take 10 minutes break and we start at 9 o'clock. Is it okay with you?
Okay.
Okay, dear. All right. So see you all in at 9. All right. 9 dah ya? Alat tak saya. Alik. Right, so are you all okay? Can we start now? It's 9 o'clock already, 9:01 already. Right, so let us start with the last review point of power series. Mana pula dah tak bergerak pula dah. Okay, which is principle of superposition. Okay, this one is not easy, but the principle of superposition says that when you solve an ODE later on, so ODE kita ni, there's a lot of types of ODE. What we are looking at a second order ODE. We have third order. You have done first order in 435, right? You know how to solve first order using I think 4 methods, separable, integration, and so on. All right. ODE on 435, you also have the constant polynomial coefficient of second order ODE. You use undetermined coefficient method, done. What we have here is the second order ODE still, but we have variable coefficient instead of constant. So this one we solve using series solution, guna power series lah, right? Sama ya, concept when you have quadratic. Let's say I have x squared plus 4x plus 4, plus, bagian senang lah, bagian susah, kali plus 3. What would be the roots for this quadratic function? Roots dia apa? Kalau kita cari nilai x dia dapat berapa? Ada berapa nilai x untuk quadratic function? When you solve this problem. Kita akan dapat apa? Ya, betul. X sama dengan 3. X sama dengan 1. Betul tak? Oh.
Betul.
Yeah. So, whenever we have quadratic, jawapan mesti ada 2. Whenever you have linear, jawapannya mesti 1 roots. Kalau kuadratik ada 2, kubik mesti ada 3. Kalau ada x kuasa 3 sampai kosong, then you have 3 roots. Sama macam ODE ya. Whenever you have first order, there's only one single solution. But whenever you have second order, dia mesti ada 2. Y1 dan Y2 as the solution. But principle of superposition says not only Y1 atau Y2 wajib as the solution, but dia kata linear combination. Linear combination of C1Y1 plus C2Y2 is also a solution. Right? So ni dia punya theorem. You can look it at snipping kita panggil. I snip from the textbook, right? This is the theorem. Okay. Sama macam kaedahnya, okay. The concept, kenapa banyak sangat jawapan ya? Think of the solution of, let's say when we have integration of a function. Remember that in integration, when we have a function f of x sama dengan x kuasa 2, when you differentiate, kita dapat apa tadi? 2.
2x.
Kalau dah saya ada x kuasa 2 tolak pi, derivatifnya saya dapat apa?
2x.
We know that integration of derivative, kita akan dapat balik function, betul? 2x, if you deintegrate, dapat balik function di x squared, betul? Betul, yeah, correct. But there are a lot, many more of derivative. Yang ni pun derivative, ini pun derivative, where you have a different function. Bermaksud that's why we ada C there, because bila kita kata tambah 3 tolak pi, tambah 10 tolak negatif pi, tambah square root of 2, kan? All this will give you the same derivative, which is 2x. Nampak tak ni? Bermaksud slope 2x ni ada banyak function yang mempunyai slope 2x. So because of this, right, that's why we put a C there. And that C representing the general solution of all the integration of derivative. Nampak tak ni? Kita mengambil inisiatif untuk semua, tak tinggal satu pun. Nampak Sama juga di sini. When we solve later on second ODE, kita akan dapat dua ni je yang kita dapat. Y1, Y2. Tapi kena ingat, solution dia, principle of superposition says that, bukan cukup dua Dia kata C1Y1 plus C2Y2 is also a solution. Contoh lah kalau kata ODE, kita dapat Y1, Y2, solution dia boleh jadi Y1 tambah 2Y2. This is still a solution untuk jawapan ODE kita tadi. Kita boleh kata Y sama dengan 4Y1 tambah 7Y2. This is also a solution for ODE yang kita solve ni. Awak faham tak ni? So untuk dapatkan keseluruhan we call it inclusive answers, we call it general general solution, you should put everything. Kita kena buat semua. So that's why the general solution should always be Y equals to C1Y1 plus C2Y2. And this will be in step 9. Remember the 9 step that I told you last time? So there will be the step 9 representing the everything final answer for your conclusion. Okay, itu sahaja. Ada apa-apa soalan? Saya dah sebut power series, bermulanya power series, step 1, right? Step 2, derivative, addition ni step 5 so, saya letak kat sini, letak mouse ni kat sini. Okay, so when we have an ODE later on, kita akan solve. I said there will be 9 basic step, maksud ada additional step. Later on I will tell you. The first one is power series. Of course, we start with power series. Second one is you have to differentiate the power series. Okay, the third one is, right? Third one apa? Silap tadi. Bukan. Step 1 is power series. Step 2, this one, step 1 is you identify type of point. Bukan power series. Okay, identify type of point, that will be the first one. Dua, which power series to use? Nombor 2, which power series to use? It's ordinary power n. If it's regular singular power n plus r. And we have two different n, right? And then third one, we change ODE to series. And then fourth is the shifting of the series. Why? Because we want to find equivalent. Kalau tak, macam mana nak selesaikan kan? Equivalent series. Yang kelima, barulah kita gabungkan ataupun you subtract. Supaya kita nak hasilnya towards the end, kita hanya akan dapat satu single series saja. 6 is the equate the coefficient. Sebab kita nak tahu nilai coefficient kita. And then yang ke-8, this is where you write your solution, and that solution will be power series ataupun we call it infinite polynomial. And then lastly is the general solution. Ni. Nanti saya akan go through one by one. So far, we have in our review, okay, kita dah tahu dah apa bentuk power series, power n plus r, okay. Kita dah tahu dah buat shifting, nak jadikan equivalent series. Kita dah tahu dah add and subtract, right? Dan kita dah tahu dah how to write your power series dalam bentuk infinite polynomial pun tak ada masalah. Dan ini adalah step yang terakhir, general solution menggunakan principle of superposition. So far saya dah cerita 5 of these puzzles, right? And then next week when we start solving ODE later on, kita akan buat satu-satu dah sampai habis. But kita akan buat yang ni. Okay, we still have masa, then we can use step 1 lah after this. Ada apa-apa soalan? Kalau tak ada apa-apa soalan, kita continue with types of point. Ada apa-apa soalan? Oh, ada dalam, sorry saya tak, kalau tak ada siapa beritahu yang ada chat, ada orang tulis kat chat ni, mana ni tak ada pun. Oh, Mio, minta maaf Mio, right? Dia tak ada suara kan, tulis kan. For yes, this is Roman number 4. Yes, correct. Thank you. Mana pergi hilangnya dah 48 orang ni. Hilang dah. Ada apa-apa soalan before we continue with step 1, type of points?
No.
No question at all. Haziq kata tak ada. So we continue with type of points. Alright, chapter 1, series solution of linear second order. Ni baru kita masuk. Chapter 1 dah sebelum ni kita review sahaja. Okay, question is what do you mean by ordinary differential equation? Siapa boleh tahu saya? ODE tu apa? ODE, mana pen dah ya? Ya, okay. Ordinary differential equation, short form dia ODE. You have learned this dalam MET 435 versus PDE. Yang ini semua dah explain di dalam 435. Jadi saya nak review balik sikit je. ODE itu apa? Anyone? ODE itu apa?
Ordinary differential equation.
Betul. Saya dah sebut dah tadi kan ordinary. Tapi kata siapa soalan you all boleh buat ke Taylor series lagi? Do you want to do it and I look into it? Later bila kita jumpa next time. Boleh? You buat dulu and then post the answers. Saya lupa dah. Post the answers in your WhatsApp group. Dan esok saya jumpa 4C2, lusa saya jumpa 4C1 Oh really? Sorry. 4C2, 4C1 esok saya jumpa.
Madam.
Sebab kami cuti lupa. Juzul Quran kami. So 4C1 esok, 4C2 esok. So bila-bila petang ni free, lepas solat tarawih, buat satu soalan yang melibatkan Taylor series. Right? Dan hantar pada saya dalam group. So esok kita boleh bincangkan. Because tomorrow 4C2 and 4C1 is in separate online class. So lagi mudah lah sebab sikit pelajarnya dan senang saya nanti. Esok saya nak tengok at least 1 or 2 of you buat dan kita boleh bincang Soalan dia ada dalam exercise 1 and also the power review box. Okay, tadi yang lady said ODE is ordinary differential equation. Betul lah, memang tak salah, betul. Tapi apa bezanya ODE dengan PDE? Apa maknanya ODE dan apa maknanya PDE? Apa bezanya? Kalau f of x sama dengan x squared, right? And then x squared dy, katalah y tak apa. Ada letak f. Y sama x squared tambah dy dx tambah 3x sama dengan kosong. Right? Ini dinamakan apa? Ni. ODE ke PDE?
PDE.
Pardon? Tak dengar.
PDE.
Apa ni?
PDE, doktor.
PDE? Untuk berapa jelas? PDE ke ODE? Young man, can you speak out again?
PDE.
P. Kenapa? Why? Kenapa sebut PDE? There must be a reason kan? Kenapa ayah saya bagi nama saya Zaileha? Right? Why? Sekiranya kita ada, do you know this? Y equals to IR. This is a famous function of voltage equal to current times resistance, betul?
Betul.
So I want to find the derivative with respect to current times plus I have double the voltage, and then I have minus the derivative with respect to resistance lah pula. Sama dengan kosong. So what is this? See the difference? ODE melibatkan only one independent variable, whereas PDE involves two or more independent variables. Faham tak maksud independence and dependent? Kalau Y sama dengan YX sama dengan X kuasa 2, di sini independent yang mana satu? X ke Y? Ni contoh saya bagi ni. Y of X is equals to X squared. Yang mana satu independent, yang mana satu dependent variable? Guys, ladies.
X square independent.
X is independent. Variable X is independent. Thank you very much, young man. And Y is dependent. Kenapa dependent? Sebab kalau X ni kalau kita masukkan 2 dan Y jadi 4. Dia depend dengan X kan? Bila X masukkan 10, Y dah jadi 100. So Y is depending on X. X ni kau masuk apa pun, dia tak ada kena mengena pun dengan siapa-siapa. Faham? Dia boleh masuk 1, boleh 2, boleh 3, boleh sebab that's why we call it independent. Are you okay, young man? The rest of you faham ya? So
Faham.
this one again, nampak tak sini? Tadi you kata PDE. Betul ke PDE? Sebab what we have here is one independent variable. Jadi apa-apa yang melibatkan first derivative, apa-apa derivative pun with what you call it, the independent variable, satu sahaja kita panggilkan dia sebagai OD. Ordinary bermaksud one single, yang biasa, one single independent variable sahaja. Faham Manakala whenever you have two, macam ni, voltage adalah dalam current and resistance, betul tak? Voltage adalah dalam sebutan independent variable. Kita ada berapa? 2. Satu adalah current, satu lagi resistance. Dan voltage ni dinamakan dependent. Kenapa? Bergantung kepada current tu berapa nilai dia, resistance tu berapa nilai dia, itulah nilai voltage. Kalau current kita 2, resistance kita 3, nilai voltage kita jadi 6. So bergantung kepada nilai current and resistance, voltage kita akan berubah. So that's why here we have two independent variable. Whenever we have derivative in an equation, okay, together with the dependent variable, inilah dinamakan partial differential. Kenapa partial? Sebab when we have V equals to IR, when we want to differentiate, kita boleh differentiate with respect to current, kita boleh differentiate with respect to resistance. Tetapi apabila kita ada one independent variable, kita hanya ada dy dx, betul tak? Terhadap x saja. Ada tak boleh dy dz untuk yang ini? Tak ada sebab di independent variable kita x. So yang ini sahaja yang kita boleh buat. Second derivative ke third derivative ke melibatkan hanya x sahaja. Are you okay?
Okay.
Alright. So that's why here kita nama dia partial sebab kita ada first part kita with respect to current, second part kita ada with respect to resistance. Kita ada beberapa part. Kalau two independent variable, we have only two parts of derivative, right? Kalau ada 3, katalah IR J lah kononnya, J, then we have voltage with respect to, sorry, notasi saya salah, right? Voltage with respect to J pula. Tapi we don't have this in our formula, betul tak? Right. So, okay, whenever you have an equation regarding dependent with the derivative, kita namakan dia partial derivative. Yang ni PDE saya tukar colour dah bagi nampak sikit. Ni adalah, apa tak ada merah? So this is what we call PD. This one is O. Are you okay? Now you can differentiate, right? So whenever we have PDE, remember the notation is using, my name is Del. This one is derivative. Derivative kita guna tata tanda D. Okay. What are the two types of differential equation? ODE and PDE. Dua-dua ni berbeza. In chapter 1, we are dealing with ODE sahaja. Ni chapter 1. We solve using series solution. PDE bukan tak ada. Kita akan belajar juga ini. Kita akan solve PDE dalam chapter 4. Boleh ya? Untuk nak buat PDE, wait until we do chapter 4. Alright. So, apa lagi saya nak cerita pasal? Okay. Right. Notasi. Dah habis dah. Okay. Some of you banyak guna main tulis je answer. Okay. Main guna saja. So, let me remind you, every single symbol in mathematics ada nilai. Same as when I said plus dot, it means towards infinity. There's only 3 dot ya, jangan lebih dan jangan kurang. Right? Sama juga dengan sebutan yang lain. Let's say I have this, tak naklah merah. Okay. So let's say I have this, this one, this one, this one, this one, and this. Banyak lagi salah, ada satu. Betul lah ya. Tak cantik betul ya. Bagi cuci macam cantik sikit macam ni. Betul. Macam mana you all buat cantik-cantik? Saya tak cantik kan tahu saya. Tak cantik sungguh. Buku betul Nak buat. Boleh lah ya. Okay. Right. So there are 5 different symbols here. So what is the first one names? Name for the first one. Dia tukar colour lah hijau. Right. The first one, panggilan nama dia siapa? Anyone?
Row.
I think row.
Yeah. Yeah, that is correct. Row. What does row means? In 455, you using row dalam ratio, limit ratio, betul tak? Limit of ratio, you use row, am I right?
Yes.
Limit of ratio. And then dalam physics, mungkin kita guna sebagai thickness kan, banyak row ni as define. Dia ada banyak. You define row ni macam-macam ada. Okay. And what is this? Yang ni lah. Apa ni? D ni. Apa nama dia? Nama dia D lah kan. Tak ada tukar lah nama dia kan. Orang semua panggil dia D. Ada orang panggil dia Dodo ke Dada ke. D je kan nama dia. Betul tak?
Yeah.
And what does D representing? Ordinary derivative. Biasa nak differentiate guna D lah. Are you okay? Right. So what does yang ni pula? Dia macam small bean sprout, betul tak? Toge. Betul tak? Comel je ha. So what does this mean? Nama dia siapa?
Del.
Del ke ni? Ini magah kawan ni. Nama saya sini lah. Ni nama dia siapa? Siapa dia?
Delta.
Ya betul. Nama saya Delta. Setengah-setengah sepupu sepapak dia kata ni pun sama juga, betul tak? Ni pun orang panggil Delta juga. Malah nak tu ada. Pun sama ya Allah. Mana pen saya? Ni pun sama juga Cantiknya segitiga ni. So apa maksud Delta ni? Apa maksud Delta? Kan belajar kan ni? Ni kan? Apa maksud dia ni?
Difference.
Difference apa? No, it's not difference. Ini kita belajar dalam limit kan? Definition of limit. Bukan difference ya? Bukan difference. This is rate of change. Betul tak? Kalau kita ada y, rate of change y respect to x. Betul tak? Katalah kita ada delta x, rate of change with respect to x. Ni rate of change ya. Yang last kali siapa nama dia?
Sigma.
Sigma. What does sigma stands for? Standard deviation dalam statistik. Kalau sigma squared adalah variation. Tapi kalau dalam physics, mana ejaan fizik? Allah tulisan. Pen saya pun dah biar kurang. Kalau dalam physics, delta means density betul. Right? Kita guna delta sebagai density and it goes on. Del ni yang kita namakan partial derivative. Nampak? That's why saya kata partial V voltage with respect to current. Partial voltage with respect to a resistance. menggunakan tata tanda del. So please make sure you use the correct notation in MAT 580. We do not have partial derivative di dalam chapter 1, but we are going to see this in chapter 4. We are only dealing with the ordinary derivative. Kita langsung-langsung tak ada guna delta dan kita langsung-langsung tak nak guna sigma. Begitu juga dengan rho. So please take note of this. Jangan salah guna notation. Kalau tak saya pakai besar saja because it means different. Are you okay so far, young man, ladies? Boleh ya? So please take note of this. Right. Okay, dah habis the second order ODE. So second order linear homogeneous or non-homogeneous ordinary differential equation, ni dia punya standard form. To know which order of the ODE depending on the highest derivative in the equation. If the highest here is the highest is 2, kita ada 1, that's it. Ada 2 je. Okay, and the highest is 2, we call it second order. Kalau the highest kat sini instead dia ada 2, tiba kat sini alah saya nak letak 3 lah pula. So the name for this ODE kita namakan third order. Boleh? Are you okay? So this one is just second order, right? Linear homogeneous. Kenapa kata linear? Okay. Apa bezanya linear dengan non-linear? Right? Saya lihat sini. Apa beza linear dengan non-linear? Apa bezanya linear dengan non-linear ODE? Bukan polinomial, ni ODE. Fix standard. Tadi saya tak masa ni saya tak. Okay. Tak keluar pula tu, tak apalah. Alright, so we have linear ODE versus non-linear. There are 3 category, okay. Whenever you see this condition, ini syarat whenever you see this condition, non-linear lah dia. Pertama, whenever you have your dependent variable, okay, lebih daripada power dia lebih daripada 1. Okay, y 4 ke, y 10 ke, whenever you have this. So that will be non-linear. Kalau linear, y dia mesti 1 saja. Power dia mesti 1. Yang kedua, right, derivative you pun power dia 1. Bermaksud kalau ada derivative darabkan yang ni tak boleh. Dia jadi non-linear. Kalau you ada second derivative kemudian dah kuasa 2, dia dah jadi non-linear. Ataupun you have dy dx darabkan dengan second derivative respect to x jugalah, pun di kategori sebagai non-linear. Kalau linear mestilah dy dx sorang-sorang ataupun second derivative respect to x sorang-sorang dia je. Kuasa dia adalah 1. Dia tak didarabkan dengan function dependent variable, dia tak didarabkan sesama derivative. Yang ini non-linear. Yang ketiga, whenever you have transcendental function. Okay, whenever you have transcendental function, apa maksud transcendental? Iaitu apabila kita ada tangent of y squared, kita ada cosine of derivative whatever lah kan, ataupun transcendental function lah. Tak nak derivative dan penting kan. Contoh. Okay, y sine of whatever lah, 5y and so on. Whenever you have transcendental function, itu kita namakan dia sebagai nonlinear. Untuk linear tak ada. Itu maknanya linear dan mana tu? Okay, so habis. Homogeneous is or non-homogeneous bergantung pada apa yang kita ada di sini. Kalau f of x kita namakan non-homogeneous, bila f of x tu kosong kita namakan dia homogeneous. Whenever it's kosong. If x is 0 then ODEs are homogeneous, otherwise non-homogeneous. Are you okay? So dalam MAT 580 kita ni, kita hanya akan find the solution of wajib second order dan kita hanya melihat kepada linear saja. Tak masuk non-linear yang banyak-banyak tu, tak ada. Everything must be linear. Cuma kat sini kita boleh dapat homogeneous, kita boleh dapat juga non-homogeneous. Dua-dua jenis ni kita boleh selesaikan. We are going to solve this ODE at a single point x0 where x0 is an element of any numbers daripada real number line. Bermaksud this ODE nanti you can, saya akan ask you to solve at x0 equals to 4. Saya akan ask Liana solve this particular ODE at -5. Saya suruh Daryl solve this ODE at x0 equals to 10. Saya suruh apa yang lagi ni? Ashikin solve this problem at x0 near infinity. Boleh? Right, so this is what we want to do next in chapter 1. When we solve a problem, we solve at one point at a time. Kita tak boleh ada banyak point, nak satu problem, kita buat serentak. No. Kita tak buat macam tu, kita hanya boleh buat once, satu solution, satu x0 dan kita solvekan. Apa benda yang not. Okay? Ada apa-apa soalan? So this is the theorems from Boys-Free-Bar yang saya tunjuk. And then when we solve this x0 later on dalam ni, kita akan dapati bahawa x0 kita terpulang kepada dua kategori. Satu adalah dari kumpulan ordinary dan satu lagi dalam golongan kategori singular point. Macam mana nak bezakan? Betul tak? 4 ordinary ke dia? 95 ordinary ke dia? 10, right? Dan seterusnya. So how to distinguish? Ni. You have to. In order to know the type of point, yang ini you kena remember. Whenever the output for your P of x is not 0, then x0 should always be ordinary point. Whenever the output of your x0 in polynomial P, which is 0, then it should be called singular. Yang ini untuk singular. Apa tu P? P tu kat mana? Ni sini. The coefficient of your second order differential, that will be the Px polynomial that you have to check for your x0. Are you okay with that? Clear ke?
Okay.
Alright. So when your Px0 output dia kosong, Singular ni ada dua jenis lah pula, Allah Akbar. Okay. One is regular singular point. Another one is irregular singular point. Okay. So a regular single point and irregular singular point. Okay. How do you know whether it's regular? This one you know in MAT 455. You have the first limit and also the second limit. If both limit converge, when both limit converges, dia akan jadi regular single point lah dia. If there's only one, salah satu dari sini, salah satu atau dua-dua, salah satu diverge, alamak, the first one diverge, maka irregular singular lah dia. So you have done this in MAT 455. So make use of the knowledge how to find the limits, converge and diverge of a point, then you know what kind of point that you get for your ODE. Are you okay? So determine all the ordinary points and singular point. Yang ini kita akan bincang hari tomorrow lah. Saya bagi example, is it okay? Ini saya ada lagi tapi sebenarnya jawapannya dah ada lah, tapi tak apalah. Kita bincang esok macam mana. You can always read so that you can have an idea. Sebab jawapannya saya dah bagi dah semua ni. You can have an idea of how to go about this. Right? Itu sahaja untuk today. Ada apa-apa persoalan? Anything that you want to ask? Esok saya akan sambung type of point with the example. You can go through my notes. I've already given you my notes. Then esok lagi senang nak bincang because you already know. Nak tanya terus soalan pun boleh. Ada apa-apa persoalan? Together with Taylor series esok Ada apa-apa? Saya stop presenting.
So far, no question, madam.
Ya, siapa sebut tu?
Daryl.
Daryl, thank you so far. Yang lain pun hopefully tak ada. Right? If you have any question, let me know tomorrow and then we can discuss it. Alhamdulillah for today. I know you have another class at 10, all right? So please be prepared for that class. Alhamdulillah for today. I'll see you all tomorrow with more topics on the type of points and then and we have another discussion, all right? I end our session with Alhamdulillah for today and I end our session with Assalamualaikum warahmatullahi wabarakatuh. See you tomorrow. Bye-bye, dear.
Thank you, madam.
Okay, don't forget attendance, attendance your future, attendance your future. Please sign in your attendance at the end. All right, welcome, dear. Welcome, dear. Welcome.